In this video, I'm going to just continue talking about trig identities. We didn't have quite enough time to get through them in the last video. So this will be part 2. We're going to start with what are called co-function identities, and those will look something like this. Again, this angle symbol could be an x variable. It's just representing an unknown angle measurement. So it could be a variety of symbols in there. But the sign of this quantity here, which is essentially 90 degrees or pi over 2 minus an angle, that identity is going to be equal to cosine of an angle. And the same could be true for cosine. If we had cosine of that quantity, that would be, that would be equal to sine. And so these are also known as difference formulas. I'm going to do a video about difference formulas, and when I do that, I'll kind of take you through it and show you why this is equal to cosine. So we'll have to wait for that video. For now, just believe me when I say that the sine of this quantity is equal to cosine, cosine of that quantity is equal to sine, and we could do the same thing with tangent. Tangent, it has a slightly different pattern here. Tangent of that quantity is equal to its reciprocal, which is cotangent. So it doesn't quite follow the same pattern as these last two, so just be careful. And also cotangent of the same quantity is equal to tangent. And we could do the same thing with secant and cosecant. Secant of this crazy quantity is equal to cosecant, and therefore cosecant cosecant is equal to secant. So these are your cofunction identities, and they relate to difference formulas, and we'll get a video going of sum and difference formulas and see why this is true, but for now just know the identity. Right. Another type of identities, sometimes called negative angle identities, or they could be called even and odd identities. So if you talk about even and odd functions, these are more of those, just some relationships of those. I like to call them negative angle identities because they look like negative angles. So if I have sine of a negative angle here, it would also be the same as if I just took the opposite of sine of that angle. And I can do the same thing with the reciprocal. So cosecant of a negative angle follows the same pattern. It would be negative cosecant of that angle. And those would be referred to as odd identities. Tangent holds true with the same pattern here. So tangent of a negative angle is going to be equal to the opposite of the tangent of that angle, and its reciprocal cotangent follows the same pattern. Cotangent of a negative angle is equal to the opposite of the cotangent of that angle. So those are all known as odd angle identities or negative angle identities. The function that does not follow the same pattern is the cosine function, and this is known as an even identity. because if I try the cosine of a negative angle, what I end up getting is the positive cosine of that angle. So not quite the same pattern. That's why it's known as an even identity or an even function. And its reciprocal, secant, follows that same special pattern. So the secant of a negative angle is going to be the same as just the secant of that angle, the positive. Alright? So those are negative angle identities, or even and odd identities, also known as even and odd functions, if you know those patterns. Alright, so those are the last little bit of identities that I'm going to talk about. If you know all of your identities, then it helps when you need to simplify or verify trig identities. So in the next video, we'll try simplifying and verifying and practice using all of these identities. So I'll see you in that next video.